This section is 5.6, which is dividing polynomials. So we're going to start with dividing by monomial, which is a polynomial with just one term. So for this monomial, we can use the property of fractions. If you have two fractions, a over c plus b over c, and they have the same denominator, you can just add their numerators and make it one fraction. Well, you can also break this down. If you have a fraction with something added in the denominator, you can decompose that into a over c plus b over c. So we're going to use that here in some examples. So I'm going to divide 9t squared plus 6t, 9t cubed plus 6t squared by 3t squared. So the first thing you want to do when you're dividing in algebra is always write it as a fraction. And now I'm going to break this up into two fractions. Two fractions added together. So I have 9t cubed over 3t squared plus 6t cubed over 3t squared. That should be a squared as well. Okay, so here I can cancel out any common factors. So that's going to be a 1, and that's going to be a 3. And then I have a t squared here and a t cubed on top. So that is just going to be 3t because two of those t's on top are going to cancel out. Then here I have t squared over t squared. That just cancels directly. And I have 1 and 2 if I divide those both by 3. So I'm going to just have 2. So 9t cubed plus 6t squared divided by 3t would be 3t plus 2. This works for any problem with where you're dividing by a monomial. So the only thing that you have to keep in mind is keeping track of your exponents. So if we have 15x to the 4th plus 20x squared minus 10x over 5x squared, I'm going to break it down into 3 fractions because there's 3 terms in the numerator. So x, first I'm going to just work with the coefficients. 15 is 5 times 3. And then x to the 4th divided by x squared is going to be x squared because when you're doing division with exponents, you use the quotient rule, which is so I'm subtracting 4 minus 2. So I'm going to end up with 3x squared. Then for this one, I can divide by 5, both top and bottom. That's going to leave me with a 4. Then x squared divided by x squared is just 1. So this is just going to stay 4. And you can see that from the quotient rule too. If I had x to the 2 minus 2, it's going to be x to the 0, which is 1. Now here, I can cancel out the 5 again and get a 2. But what's going to happen here when I have an x in the numerator and an x squared in the denominator, so you can think about it 2 ways. One way you could think about it is that you have x over x times x, which is what x squared is. So I could cancel out one of them and be left with an x on the bottom. The other way you could think about that is using the quotient rule, because I have x over x squared, which is x to the 1 minus 2, which is x to the negative 1. and that equals 1 over x. I think it's easier to think about it this way, just thinking about how many x's you have on the bottom and top, because then you can just cancel. So one final example of dividing with monomials. I'm going to do a division problem with more than one variable. Over 4xy. I'm going to break it down into 3 fractions. So here I have 16 divided by 4, which is 4. And then x cubed divided by x is going to be x squared. And y divided by y cubed is going to be y squared. 20 divided by 4 is going to be 5. And then the x and y's are going to just cancel out to be 1. Then in this last term, the 2 and 4 can reduce down to 1 over 2. And I can cancel out the y's, but I'm still going to be left with an x in the denominator. So this would be my answer to that problem. So that is how you do polynomial division when you only have one term in the denominator. But if you have 2 terms in the denominator or more, then you won't be able to do this method. So if you remember from elementary school, you would do division, like if you had 46 divided by 10, you would set the problem up like this. You'd have 10, 46 under this little box, and then you would multiply 10 by whatever would give you the closest number that was smaller than this. So 10 times 4 would give you 40. And so you would put a 4 up here, and then you would subtract that from that and get 6. And then 10 doesn't go into 6, so I'd keep adding digits and so on and so on. We're going to do a very similar thing with polynomials. So I'm going to divide x squared plus 7x plus 12 by x plus 3. So I'm going to take the x plus 3 and put it outside the box. And I'm going to take the trinomial and put it inside the box. And so now what I'm going to do is I'm only going to focus on the leading term. I want to multiply this by something that will give me x squared. So I'm going to multiply this by x. So that's going to give me x squared plus 3x if I multiply both of these by x. Now, this is the tricky part where people tend to get things backwards. You are subtracting all of the terms here from this. So x squared minus x squared is 0. 7x minus 3x is 4x. Now I'm going to carry down that 12x. So now I am trying to get this x here to become a 4x. So I'm going to multiply this whole thing by 4. And so then I'm going to do 4 times x is 4x, and 4 times 3 is 12. And so if I subtract this from that, I'm going to end up with 0. So that means I don't have a remainder. So my answer is just going to be x plus 4. Another thing that you have to be aware of when you're doing this is called long division. By the way, this is polynomial long division. Another thing that you have to be aware of is that you need to have all of the possible powers of x accounted for. So if I have this problem here, I'm going to take x minus 3, and I have x cubed, but I'm going to write in a plus 0 x squared, because even though there's not an x squared term listed here, there is one implied, and I have to keep all of these powers of x accounted for in the long division, just like you have to think about decimal places when you're doing long division with numbers. So now I'm going to do the same thing. I want something I can multiply by x to get x cubed, which is going to be x squared. So I multiply x squared by x, get x cubed. X squared by minus 3 gives me minus 3x squared. Now, subtracting everything in these parentheses here. So if I do 0 minus negative 3x, I'm actually going to get positive 3x. So now, I want to find something I can multiply by 3x. And you can carry this 27 down or not. I usually like to carry it down with every step. So I'm going to multiply by 3x up here. 3x times x is 3x squared, and 3x times negative 3 is negative 9x. Again, I put the parentheses and I subtract. And so that is going to be 0 minus negative 9x, which is positive 9x, minus 27. And then I need to multiply this x by something that will give me 9x. So that's going to be plus 9. I'm going to get 9x minus 27. That's going to leave me with a 0, so I don't have a remainder again. So my answer is x squared plus 3x plus 9. So now we need to go over what you're going to do if you have a remainder. So here's an example, and I am going to have to put these in order. So I have a 8x cubed. I don't have a an x squared. So I'm going to put a 0x squared. I have a positive 12x and a minus 4. So this is going to be what I'm dividing. So now I'm going to try to find something to multiply 2x by to get 8x cubed, which would be 4x squared. I'll get 8x cubed. And then 1 times that is plus 4x squared. Subtract everything. And since this is subtracting positive 4x, I'm going to get negative 4x squared plus 12x minus 4. So now I want to multiply this by something that will give me negative 4x. So I'll do negative 2x. that would be negative 2x here. So 12x minus negative 2x is 14x. And then I'm going to multiply 2x by 7. Then 7 times 2x is 14x. 7 times 1 is 7. And then the 14x's will cancel out. And I'm going to do negative 4 minus 7, which is negative 11. So this here is my remainder. So in my answer, I'm going to have minus 11, and then it's going to be divided by 2x plus 1. So my answer, so if you have a remainder, you're always going to write it as a fraction over the polynomial that you were originally dividing everything by. So those are the basics for how to do polynomial long division.